Okay, so we can now work with forces that act at an angle. In AS mechanics, you met Newton's laws and Newton's second law, F equals ma. So in A2 now we can extend the complexity of the problems you were working with last year. So let's take a look at this fourth example. A body of mass 4 kilograms has an acceleration a when it is acted upon by a force of 25√2 newtons, which is inclined at 45 degrees to the smooth horizontal surface on which the body rests. By resolving the forces parallel and perpendicular to the plane, calculate the normal reaction between the body and the plane and the acceleration a of the body. Okay, so we want a nice clear diagram to put all of that information on. So there's my surface. There's my body. It's got a mass of 4 kilograms, which means it's got a weight of 4g. It's being acted upon by a force of 25√2 newtons, which is inclined at an angle of 45 degrees to the horizontal. So that's going to have an fx component there and an fy component there. Now, because it's in contact with the surface, that means that it has a reaction force as well. So that's the normal reaction, and that acts at right angles. They want the forces resolved parallel and perpendicular to the plane, and we generally take the direction of motion to be positive. So my plus x is going to be there, and my plus y is going to be there. So that would be my fx. That would be my fy. Now it's accelerating, so we're also going to have an acceleration in that direction. So when I'm doing the sum of the forces in the x direction, then Newton's second law will apply. Okay, and the fx, the sum of those fx's will equal the mass times the acceleration. There's no acceleration in the vertical plane, so fy, there's no acceleration. So therefore, the sum of the y forces will be 0. They're in equilibrium. Okay, so first of all then, let's resolve fx. So fx is going to be the horizontal component of that, which will be 25√2 cos 45. There's no resistant forces, there's nothing else acting horizontally, so that will equal mass, which is 4, times the acceleration, which we don't know. So from that x equation, the only thing I don't know is a. So I could work it out straight away, but what I always advise is when you're working with a mechanics problem, get all your equations written first and then move over to calculating the unknowns. So that's going to give me my a, and then when I resolve in the y direction, I've got positive r plus 25√2 sine 45, that's the opposite of the 45, minus 4g, acting entirely in the negative y direction, equals 0. So from equation 1 I can get a. So a will be 25√2 cos 45 divided by 4. In these wonderful worlds of the new calculator, you haven't got to worry about knowing that 45 is 1 over root 2, so you can put that in as a fraction. Top line 25 root 2 cos 45 all over 4, and get the answer 6.25. Meter per second squared. And then for 2, you want to get the r on its own, so you can take the 4g over, it was positive, minus 25 root 2 sine 45. So we're going to do 4 times 9.8, take away 25 root 2 sine 45, close bracket, 14.2 newtons. But whenever we have a line of maths where we're using acceleration due to gravity, if we're using the acceleration due to gravity of 9.8, that means we're taking the g to 2 significant figures, which means we don't then give an answer to any greater degree of accuracy than that. Okay, so I'll just make a note of that there. If g equals 9.8, i.e. to 2 sig fig, any solution to equation containing g also needs to be given to 2 sig figs. Now, on an exam paper, if you don't do that, they'll penalise it once on the paper. Okay, so my answer there is going to be 14 newtons, 2 sig figs. Okay, it didn't matter here because that particular line didn't contain g. Okay, so that's something just to be mindful of.